Hello and welcome. In this video, I want to discuss this particular limit. This limit is a little tricky. It involves some things that you don't usually have to think about when you solve a limit problem, especially a graphical limit problem. Okay? So, let's jump right in. We're asked to find the limit as x approaches -1 of f of x. Okay, so the first thing to notice is that f of x is the input, not the output. F is the input, and that is, f is the input, and that is inserted into f again to produce the output, and we want the limit as x approaches -1. Okay, well, first, let's talk about the following. Let's talk about the limit as x approaches -1 of just f by itself. Okay, so this, of course, involves a left-hand limit and a right-hand limit. So the left-hand limit as x approaches -1 from the left of f. Oh, that's going to, okay, here's -1. And as we approach -1 from the left, we're talking about this, okay? And as we can see, these little markers are getting closer and closer and closer to the y value 2, okay? Likewise, the limit as x approaches -1 from the right, once again, these little tracers, these little markers, are getting closer and closer and closer to y equals 2. Okay, now, okay, good. So at this point, you might be tempted to do the following. So I'm going to change my color here to blue. And if you're not careful, then you will fall into the trap that I fell into when I first looked at this problem. And that is, you say, okay, well, this limit is 2, so I'm just going to insert that here, and I'm going to, okay, well, let me see here. Yeah, basically, you can say, okay, we evaluated the limit, so this is 2, so all I need to do is find f at 2, okay? And if we look at x equal 2 here, f at 2 is exactly 2, because this is 3, we got 1, 2, 3, so f of 2 is 2, and you might be tempted to say, okay, that's the final answer, we're good to go. But that's wrong, okay? And I want to discuss why this is incorrect, okay? First, let's look at this again, okay? The limit as x approaches -1 from the left, it is certainly, as we can see again, it is certainly approaching 2, but I want to point out specifically that y is approaching 2 from below. Y is approaching 2 from below, okay? So I'm going to put this, okay, well, I need to go back to green. Green. Y is approaching 2 from below. All right. Same thing for the right-hand limit. Okay. The right-hand limit, nothing goes above 2. Okay. In fact, nothing even touches 2. Okay. So this is approaching 2 from below. Okay. So I want to point this out. Okay. There is no path. Okay, let me say it a different way. F of x has no path that exceeds y equals 2 in the neighborhood of x equal -1, okay? F of x has no path that exceeds y equals 2 in the neighborhood of x equals 1, okay? F of x approaches 2 from below in both cases. Okay, and this f of x, this very same f of x, is the input of f, because it's f of f. It's f of x. So the y value becomes the input, and the y value, as we can see, only approaches 2 from below. Okay? So because of that, we are forced to conclude the following. Okay? We are forced to conclude that the limit as x approaches -1 of f is going to equal the following. It's going to equal the limit as x approaches 2 from the left of f of x. Okay? Because we evaluated this limit and we got 2, but neither side, the left side of -1 or the right side of -1, never exceeded 2. So it never approaches 2 from above. So we are forced to only consider the limit as x approaches 2 from below. In other words, 2 from the left. Okay? And if we look, here's 2, and the left-hand limit of f as x approaches 2, as we can see here, is going to be 5. Okay? So this limit is going to be 5. Okay? Again, this is not an easy problem. I hope that this explanation makes sense. I would like to hear from as many people as possible. I've interacted with a few teachers about this, and there's some teachers out there who disagree with me. I hope that this explanation has been satisfactory. Again, I know it's not the simplest thing in the world, so I don't know. Please reach out to me if you're a student or a teacher and you're having trouble understanding this line of reasoning. All right, I want to call it.